Now we're going to be looking at piecewise functions. A piecewise function is a function that is broken into pieces over its domain. Each piece of the function has a different function rule for that part of the domain. So the different intervals have different formulas to represent that function over that particular interval. Here's an example of a piecewise function. We read this: f of x equals negative x if x is less than or equal to 3. F of x equals 2/3 x minus 4 if x is bigger than 3. Now what this means is whenever we are from negative infinity until positive 3, we look like this line, y equals, this right here is the same as saying y equals negative x. And then whenever we are bigger than 3, when x is bigger than 3, I look like the line y equals 2/3 x minus 4. And you can see that in the picture here. So from 3 and less than that until negative infinity, we look like the line y equals negative x. And then from 3 on to positive infinity, we look like the line 2/3 x minus 4. Here we have an example of what's called a step function. So this step function literally looks like little steps and is not defined over the real number system. It's only defined between x equals 0 and x equals 6. So from 0 to 2, we look like the line y equals negative 2. And then from 2 to 4, where y equals negative 4. 4 to 6, where the line y equals negative 6. Notice how when we define the interval, only one of these has an open or closed dot on them because only one has the equal to sign. So this is going to ensure that we still remain a function, because at 2 we cannot have two closed dots because then this would not be a function. In order to evaluate a piecewise function, we first need to figure out in which bucket does the number we want to plug in belong. So when I plug in the number 4, which bucket does it fall into? So 4, let's look at 4 and let's look at our domain. So the number 4 here, where is it going to fall in my domain? Well, is 4 less than or equal to 1, or is 4 greater than 1? Well, it appears that 4 is going to be greater than 1, so when I plug in 4 into my function, it's going to fall into the negative 3x bucket. It's going to be in this domain. It's going to exist on this interval. Therefore, f of 4 is going to exist on this line here, negative 3x. So I'm going to plug in 4 into that part of the function rule. Therefore, f of 4 is going to be negative 12. So that means that the coordinate point for negative 12 exists on this graph, and it's going to exist on this part of the line, negative 3x. Now, if I want to find f of negative 2, again, we're going to plug in negative 2 into my function. So I'm going to plug in negative 2 and see where it falls. So is negative 2 less than or equal to 1? Yes, it is. So it's going to fall in this bucket, 2x plus 1. So I'm going to use that rule now for negative 2. So f of negative 2 is going to fall into the 2x plus 1 bucket. So plugging in negative 2 there, evaluating that, I get negative 3. So f of negative 2 is negative 3, and that means that the coordinate point negative 2, negative 3 will exist on my graph, and it's going to exist on this part of the graph that looks like 2x plus 1. So let's give these a try. F of 0, I plug in 0 into my function, and where does it fall? So I check over here in my domain intervals. 0 is going to be greater than negative 2, so it's going to fall into this bucket here. So plugging in 0, f of 0 goes into the negative x bucket, so negative 0 is just 0. So f of 0 equals 0. Now when I plug in negative 2 is going to fall into this part of the domain because negative 2 is equal to negative 2. So it's going to look like this part of the graph at negative 2. So plugging in f of negative 2, it's going to go into the x plus 4 bucket. And I'll just get positive 2. So f of negative 2 equals positive 2. Alright, so now we're going to try to graph, okay? Now the trick to this is you actually need to graph the entire line but then we're actually only going to leave the section of the graph that we need, okay? So I need to graph this line, and then I'm going to erase anything that's bigger than -2. So starting here, I'm going to plot my y-intercept, which is 1. Okay, now since I'm less than or equal to -2, I know I don't need to graph the things to the right of that red dot, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, now I don't need anything that is bigger than -2, so I'm going to erase these guys. Okay, so yes, right here is so right there is -2, so I erased everything to the right of -2. Now, from everything bigger than -2, I have the value of 5, okay? So I'm going to go over to everything bigger than -2, and I'm going to be y equals 5. So I'm going to go up 1, 2, 3, 4, 5, and I'm going to have an open dot. Now, why is it an open dot? Well, look right here. There's no equal to sign there. And then I'm going to be a horizontal line at y equals 5. And it's going to keep going. All right? So from the left-hand side, I'm going to have a closed dot here. And then I'm going to draw this line. All right? I know it's a little confusing, but this is what my graph is going to look like. So from -2 and less than, I have the line 2x plus 1. From -2 and greater than, I have the line y equals 5. Okay? So I'm going to write my x and y axes. I want to go ahead and label this point because it's kind of important. -2, 5. Label this guy. So that's -2, -3. Okay? And if it makes you feel better, you can label the sections of the graph that they correspond to. You don't have to do that. But I think it helps. It helps for people to understand. Alright, so here is another example. So for everything bigger than 1, I'm going to be this function right here. Everything less than or equal to 1, I'm going to be this function right here. So I'm going to go ahead and start graphing the first one, okay? So my y-intercept is 3, so 1, 2, 3, up 3. And then my slope is -2, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Keep going. Alright, now I only actually care about things that are bigger than 1, okay? So my actual y-intercept I don't care about. That's not going to be part of my graph, so I'm going to go ahead and erase that. And since I have a open dot here, this needs to be an open dot on 1. And then I'm going to go ahead and graph my line. Okay? So this right here is for x bigger than 1, and that's an open dot. I have -2x plus 3. And then for x less than or equal to 1, I need to graph x plus 5. So I'm going to go up to x plus 5. My y-intercept is positive 5. 1, 2, 3, 4, 5. And then my slope is 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. See, these graphs can kind of look funky. Down 1 over 1, down 1 over 1. Just keep going. Now, I drew some dots that don't need to be in my graph, okay? I only want things less than or equal to 1, all right? So these guys right here don't matter to me. And I want everything less than or equal to 1. So yes, this is going to be a closed dot. You should always have one closed, one open, all right? So now go ahead and label all my necessary stuff. These points are important, so that's 1, 1. This is 1, 1, 2, 3, 4, 5, 6. Okay? And this part of the graph is the f of x, or I'm sorry, it's g of x. g of x equals x plus 5. And this guy down here is g of x equals negative 2x plus 3. Okay, and together they make this piecewise function. Alright, so let's do another example. So hopefully you're following along and also graphing these on your own paper. So for x bigger than or equal to 1, I want negative x. So that's y equals negative x. That's the slope of negative 1. Y-intercept is non-existent, so it's just 0. Okay, and then for x less than 0, I want to be g of x equals x. So I want to be the line that has a slope of 1 and a y-intercept of also 0. Okay, so 0 is the point where they're coming together. So let's go ahead and graph this first one. So for everything greater than or equal to 0, I want to be negative x. Alright, so let's do negative x, x greater than or equal to 0. So I'm going to start on my y-intercept, which is 0, and I'm going to have a closed dot on 0. And then I'm going to have a slope of negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. Okay, keep going. Now I don't need to do my slope upward because I don't care about the values less than x for that. Okay, so I'm going to go ahead and graph that line. Alright, now for the second part of my graph, everything less than 0 is going to have a positive sloped line. Okay, so that means I'm going to go from 0 here. It's going to be an open dot, so notice how they kind of overlap. And I'm going to have a positive slope. Now if I went up 1 over 1, it would continue like this, but remember I want everything less than 0. So I'm going to go down 1 over 1, down 1 over 1. Keep going. Okay, so I go ahead and I connect my dots. Okay, erase the points I don't need that I wrote. And then go ahead and label everything. I have my axes, this important part here, 0, 0. Should probably go ahead and put some other points. That's 1, negative 1. That's negative 1, negative 1. And this is going to be the g of x equals negative x part. And this is the g of x equals x part. Alright, now give this one a try. And this one.